Hello and welcome to C3 Differentiation Part 1. I'm just going to take you through a few things to differentiate today. Standard questions, no tangents, no normals, no stationary points, just differentiation. One of these should come up. Right, start off with a bit of trigonometric differentiation. 4 sine squared x plus sec 2x. Now what I'm going to do is I'm going to write this is 4 sine x squared plus sec 2x. Now this is a chain rule question, okay, and you should always do that with a sine squared or cos squared. Now the 2 goes to the front, 8. I take a power off sine x and I times by the differential of sine x, which is cos x. Now then sec differentiates to sec x tan x, so this differentiates to sec 2x tan 2x, but then you times by the differential of the thing that you are secking, so the 2, so I finish off with that answer. 8 sin x cos x plus 2 sec 2x tan 2x. And just a neat trick there would be that I know that sin 2x is 2 sin x cos x. So I know that this 8 sin x cos x is actually 4 sin 2x. So I could write that's an answer. Now you don't really need to write that, that's just me being clever. Number 2. Right, this one's another chain rule question. X plus ln 2x cubed, I'm going to differentiate that. So here, I'm going to do 3, then I'm going to do x plus ln 2x. I'm going to put a squared, and I'm going to times it by the differential of a bracket. Now x differentiates to 1. And ln of x differentiates to 1 over x, but ln of a constant times x differentiates to just 1 over x. Because you're basically doing the differential over what you originally log in, so a over x, which is 1 over x. So the answer is 3, x plus ln 2x squared times by the differential, so 1 plus 1 over x, and that will be the final answer in that question. Now this is a question which can be quite neat at the end with how you simplify it. This will probably be a sure that question, but I'm not going to spoil the surprise here, so I'm not going to tell you what the answer is yet. So here we've got 5x squared minus 10x plus 9 on the top and x minus 1 squared on the bottom. Now I'm guessing there's going to be a simplification here which is to do with the x minus 1, so let's keep that in mind, okay? Now u is 5x squared minus 10x plus 9, and hopefully a lot of you will have realised this is a quotient rule question, and v is x minus 1 squared. Now u dash, if I differentiate u now, then I get 10x minus 10, and write that, guys. Okay. Then v dash, we do chain rule, so 2 x minus 1 times by 1, which is a differential of x minus 1. Now we don't want to miss a trick here, so 10x minus 10, let's be clever and realise that it is actually 10 factorised out x minus 1, and that is friends with a v dash, so there might be a cancelling thing to see later. So that's our situation. Now we know it when we differentiate using the quotient rule that we do vu dash minus uv dash over v squared, also known as VUV with some weirdos. So vu dash minus uv dash over v squared gets me 10x minus 1 cubed. Take away uv dash, which is 2x minus 1 times 5x squared minus 10x plus 9 all over v squared, okay, which is x minus 1 to the power 4. Now guys, if you look at that, you'll see x minus 1 can cancel out everywhere. So there's x minus 1 every term, so I'm going to cross out 1 there, I'm going to cross out that there, and cross out 1 there. Okay. Now then I get 10x minus 1 squared minus 2 bracket 5x squared minus 10x plus 9 all over x minus 1 cubed. Now that is where I need to start multiplying now, okay? So be careful here. Now that is 10x squared minus 2x plus 1. Take away 10x squared plus 20x, do not fall foul of that, minus 18 over x minus 1 cubed. Now that is 10x squared minus 20x plus 10 minus 10x squared plus 20x, exciting times, minus 18 over x minus 1 cubed. Okay, now then I can cancel out the the 10x squared at that time, so 10x squared and a minus x squared, minus 20x and a 20x. So I get 10 minus 18 over x minus 1 cubed, which is minus 8 over x minus 1 cubed. That is 5 marks. Okay, let's do a few more here. Number 4, right, nice easy one hopefully, if you know your stuff. 5e to 2x minus a half ln 3x minus 2. What does that differentiate to? Well, e always differentiates to e. So e to 2x differentiates to e to 2x but times by 2 because you times by the differential of the thing that you're eating. So you get 10 e to 2x. Now minus a half. Now ln 3x differentiates to 1 over x. Okay, and minus 2 differentiates to nothing. So I end up with 10 e to 2x minus top by top, bottom by bottom, 1 over 2x. Excellent. This is almost too much fun, guys. Number 5, ln of a half x. Now that is just 1 over x differentiates to 1 over x, okay? Because it's half over half x. And you do not want to be caught out in the exam with that, because they're naughty like that. Now x squared e to the 3x minus 1. Now this is a product rule, also known affectionately as UVU. So uv dash plus vu dash, okay? Now, let's write it out carefully. U is x squared, v is e to the 3x minus 1, u dash is 2x, v dash is 3e to the 3x minus 1. So I do uv dash plus vu dash, so I get 3x squared e to the 3x minus 1, plus vu dash, so 2x e to the 3x minus 1. Right, we're tearing through these at the minute. So number 7, cos of 3x squared over 3x. Now again, this is quotient rule, okay? So it's VUV. So u is cos of 3x squared. V is 3x. So u dash. V dash is 3. Now u dash is basically minus sine of 3x squared, but then you times by the differential of the bracket or the thing that you're cosing, so minus 6x. Okay. Now what you do is you do vu dash minus uv dash over v squared. So let's do that. So minus 18x squared sine of 3x squared minus uv dash, so minus 3 cos of 3x squared all over v squared, okay, which is 9x squared. Now we can divide right through by 3 if we want, and that's the only thing that I can really spot there, so I get minus 6x squared sine 3x squared minus cos of 3x squared all over 3x squared. Okay, that was another enjoyable one there. Now number 8, I have got 4e to the 2x to differentiate. Okay, now 4e to the 2x, we know from earlier, e to the 2x goes to 2e to 2x, so this differentiates to 8e to the 2x. Now 9, a quick one. Now e to the x root 5, some people fall for stuff like this, but it's exactly the same as what we just did there. It's root 5 e to the x root 5, okay? Because x root 5 differentiates to root 5. Now a couple more before we finish this one of my favourites so far of my videos. 4 over root 2x minus 3. Don't do VOO. No, we have to realise it is just 4 2x minus 3 to the minus a half. So it's chain rule, and it's not VOO because it is not. It hasn't got an x on both sides. Okay, so what we do is we bring the minus a half to the front like any differentiation. Minus 2, 2x minus 3 to the minus 3 over 2. Then we times by the differential of the bracket, which is 2. So the answer is minus 4, 2x minus 3 to the minus 3 over 2. And the last one. Okay, so I've talked for a bit long on this one. 5 plus x squared to the power 3 over 2. Now again, this is chain rule again, so you bring 3 over 2 to the start, 5 plus x squared, take a power off, a half, and you times by the differential of the brackets of 2x, so I end up with 3x, 5 plus x squared to the half. Thank you guys.